For the differential equation dy dx is x, y is 3 when x is 2, estimate the value of y when x is 3 using delta x is 0.5. Check by solving the equation and computing y when x is 3. Quite a good way of keeping track when you're doing this type of thing is to use a table. So I'm going to start with the current point just here, and at the beginning that's going to be 2, 3, our start point. Delta x, which we know or we're given, is 0.5. Then we want the value of dy dx. Then I would put the delta y value. And finally, the next point. So, we're starting at 2, 3. Our equation is delta x, or dy dx, sorry, is equal to x. So at this point here, dy dx would be 2. So delta y, we know, is dy dx delta x, so multiply these together, that gives us 1. So our next point, the x has increased by delta x, so that's 0.5. The y has increased by 1, so we get 2.54. And then that's the start point for the next row of the table. So 2.54. Delta x is always going to be the same. Dy dx is equal to x in this case, so that's going to be 2.5. So delta y is 0.5 times 2.5, so 1.125. And our next point is 3. And the y value here was 4. We need to add this, so that's 5.125. So that's our estimate of y when x is 3. So y is equal to 5.125 when x equals 3, using our estimate. Now, dy dx is equal to x, so now we're doing this bit. So the integral of 1 dy would be the integral of x dx. So y is going to be x squared over 2 plus a constant. Now we know that y is equal to 3 when x is equal to 2. So 3 is going to be 4 over 2, 2 plus c, tells us c is 1. And so we have y is x squared over 2 plus 1. So when x is equal to 3, y is going to be 3 squared over 2 add 1. So that's 4.5 add 1 is 5.5. So the exact value for y when x is 3 is going to be this one, because we got that by solving the equation. And this is our estimate. Had we taken many more steps, we would have gotten a better estimate. Now, just to illustrate this, here's a spreadsheet that I did taking delta x as 0.1, and we can see that we get to 5.75, which is closer to 5.5 than we had before. And then these are the last few lines of a spreadsheet that I did taking delta x as 0.01, and we can see 5.525. So as we reduce delta x, we should get a better estimate, but of course we have to do a lot more steps.